program control.
The German system. As the war continued, Germans designed a second, much harder to break code system, messages before transmission. Each coder
in 1977.
Very crude assembly program. So
This microprocessor was the forerunner of today's multi-billion-dollar chip industry.
Incredible impact that's had on mankind. In the same way, intelligent computing is going to open up huge areas of exploration that will make our lives better.
Now that's daunting, real.
This card you can actually get it to copy from this card to this card. So if you need to type my name is over and over, you take a card, bend it, put it over here. And what that does, REG does, it says, okay, I'm actually just registering this card over here to be able to type. So now, did you hit REG already? Maybe, okay, hit REG, register. Now it's ready for typing. Type your first name and your last name. And there's a little hammer under here, obviously, that just starts typing out. Got it? Yeah. REL stands for release. Okay. Now hit REG. REL again. REG. REL stands for release. You may be wondering, why do we keep hitting it 3-4 times? The answer is, while one card is here, you can get another card over here and then start typing a new one. It's sort of like pipelining. I mean, yeah. I don't know how far you guys are into EE, but like, I'm sure your like processor design classes talk about like pipelining pretty extensively. Yeah, so that's basically the deal. Spelled right? Yeah. Cool. Now, little cards, not very useful. So what we're gonna do is feed them into the computer. Follow me.
That's right. And then this is an online plain water industry called pre-written software. I definitely have a
I'll try it out. Exactly like what you saw under the hood of the Chih-Kuan right there. Okay. Bunch of wires, you feed it in, it reads what you're looking for, types them back out. Right? Alright. Could you unchain that for a sec? Sure. Thank you. Take these cards. Here. Wait on top.
This system exceeded IBM's wild most optimistic people.
Your card went through here, came out through here. Where does it go? Right, second drive. Bunch of data cables under here. Carry data from this to that and that to that.
So it transfers data through the wire.
Yep, from here into there.
Okay.
Now this is just the reader. All the CPU, all the memory, and all that stuff's in here. So now, this is where the outputs actually come out. This very nice line printer over here. See this little chain? Maybe you'll be able to see some letters over here.
Yeah.
Look very carefully.
Yeah.
Just like a typewriter. The chain spins around, hammers hit the chain. You can print things out 10 lines per second, faster than your printer today. Okay. Now I'm gonna hit load, and it's gonna take your data, send it from the computer through here. By the way, and if you ever like, so you guys probably program in some sort of text editor, right?
Some
you know,
type of.
You know how the line when you press enter, the physical character byte is written.
Yeah.
There's a new line character, and then there's a character store character. If you're using Windows.
Yeah.
Character store. That's the same.
Yeah.
Now. Let's hear the program. And now. And these are your cards. Okay. Hold on, let me get you the little versions.
Okay.
Oh, sorry about that. Sorry about that. Here you go. The little version and the big version. So again, the field demo is considerably longer than like 2 or 3 minutes. So if you have any other questions, anything like that, please don't hesitate to ask me. Well, this is the program. It's called, on the side, you can see we've written it out, big print, prints your name out in big letters. So ordinarily, I'd have to load this into the computer first and then load your cards in afterwards. Now, because they had a demo here earlier, I happen to know that this program's already sitting in the RAM of that computer.
Yeah.
So I didn't have to load it again. Saves me some time, but generally, yes. So that's all the data for the program, and you'll notice today's date, because it says that the date that you visited the museum.
Yeah.
Right, of course, this thing doesn't have an onboard clock, because, yeah. So you guys remember, you've heard of vacuum tubes, right?
Yeah. Yeah.
So these are a whole set of vacuum tubes. Computers used to use these, right? Problem is, A, they're very delicate. If I hand this out to somebody, 90% of the time they'll break it. It's like stupidly delicate, and they blow out all the time. So what these guys do instead are a bunch of transistorized cards, which you can actually see if you walk to the side of the computer. I guess I'll show you that. Your question was specifically about memory. So here's, you can take this in fact, take a look at, I mean not permanently, but you can look at it. Like, so that's a whole bunch of memory for the 1401. See those little iron cores, right? They just look like little iron donuts. So you roll a wire through there.
Is it used for the Saturn 1 rockets?
The Saturn 1, so there are several kinds of this memory, right? This is generally core memory. I don't know the Saturn 1 used core rope memory or core memory. This one is core memory, which can be used as RAM and ROM.
Is it because it rotates one way, it means one, and rotates the other one?
Pretty much.
Zero?
You had to sew this by hand for the first few years, so you can imagine how expensive this was.
Yeah.
Saturn 1 uses a principle similar to this,
Okay.
but do be wary that because in space, like in a weird way, like the fact that this is larger was more convenient because nowadays, like if you're in space, right, the DRAM's like an individual like memory cell of DRAM is so small that a single cosmic ray will flip it.
Yeah.
Here, it's so big that actually it's accidentally radiation resistant, right? There's no way a single particle is going to knock this out of whack.
Right.
So they had their own little variants of core memory that were sometimes ROM, sometimes bigger to survive the space, so on and so on.
I mean, do you need to count 0 and 1 like the first time for the numbers? Like,
What do you mean?
Which one rotates the one way and rotates the other one? It means 0 and 1, right?
Are you talking like mechanical rotation?
Mechanical rotation.
No, it's not mechanical rotation. You just send a little current through this. The current is wrapped around that. Little electromagnet causes the iron itself to polarize.
Okay.
And that little magnetic state is what stores it. It's not
Alright.
actually mechanical rotation. Otherwise, these things would wear out very, very quickly. Yeah. That one over there is number 1. It's not actually working at the moment, which is why we're using this one. This one over here is number 2. It's from Germany. We have a whole bunch of power converters, so it'll work on the German power standards and all that. There's one more in an IBM factory somewhere. You need to know somebody who knows somebody to actually get in, and even then, I don't know if it actually works. But if you know like IBM C or something, it lets you in this like top secret room where you can check it out. But not for people like you and me.
So the one with the round disc is the one with the round disc over there, the 3 machines. What's that for?
So these are punch cards, right? Pretty nice because you can type them and pull them out. But you can imagine they're not exactly the most dense medium to store information.
Yeah.
80 characters per card. I can show you a box somewhere around here. So 80 characters per card, about 2,000 cards in this box, right?
Yeah.
So if you want to do the math and see how much memory is actually in this whole box, it's not more than a couple of kilobytes, right? It's not a good medium to store. Plus, like punch card reading is a mechanical process, right? Like that machine reads at 10 cards per second. So if your punch card needs to bend, then 9 cards will slam into it and everything gets jammed up. So this is the replacement, right? Tape. So I'll show you around it. You all have seen these?
Yeah.
Yeah, right? The
The
set
tape?
tape?
Okay.
Yeah, exact same technology, right? Same thing as the core rope, incidentally, that we were talking about before. Except on a microscopic scale. So little pieces of iron, flip a magnet on either side, it'll magnetize this way, magnetize that way.
Yeah.
When you run it across the read head, then you can read the data back up. So eventually the hope was to throw away most of these card read punches and replace them with tapes like that. So I can show you these guys in action. It's very nice. So each one of these reels of tape has about half a mile of tape on it. So that's a lot more storage. Going on there, everything's being read from this tape head to there. Now, you look a bit to this side. Look at the bottom. See those things going up and down?
Yeah.
What's the deal with those? I'll tell you what's the deal. So, the 1401, it reads data in little bursts, right? But those reels of tape are very, very heavy. If you keep starting and stopping them, it'll just rip the tape and rip up the machine.
Right.
So what it has is that little sort of tape at the bottom is actually a little bit of dangling tape. It acts as a reservoir, so that way the tape's wheels have a little bit of slack to pick up and catch on. And see how they keep going up and down? How does it know when the reservoir is empty and to put more tape into the reservoir at the bottom? Well, there's actually a little vacuum down there, that little hole, see? And what happens is when the tape crosses that vacuum, it senses the change in pressure. It's like, whoop, I must be running out of tape. Time to spin the big wheel and get all the information.
So it's preventing from breaking in half.
Yes, the tape. So you can have these guys run at many speeds, and once you're done with them, you can press the rewind button, right? Because obviously you don't want to spin it at this speed, and it'll rewind that whole half of a mile of tape in just about 10 seconds. So I don't know how fast a Ferrari is, but about half a mile in 10 seconds is a very good speed, I think, for a 6-year-old machine. So I'm not going to demonstrate the rewind now because I actually got to let them wind up for the next demo at 1 p.m. That's generally what's the deal with the tape machines. So yeah, unfortunately these couldn't completely replace paper cards. You still needed them for some situations where like you're loading data or stuff like that. But all in all, they're a whole lot better than those.
Critical course at the Model Railroad Club and elsewhere said that's a great idea. Why don't